Florida Tech joined the Kern Entrepreneurial Engineering Network in 2015, and these are the team members throughout the College of Engineering and Science. Uh, we've had a presence at the last, I guess, 6 Keen national conferences, and I've given a talk in 2017 on questions and issue sheets, and we gave a couple of seminars related to this grant and making in 2020. The purpose of our first grant was to establish a presence in each engineering program. That went well. The current goal is to develop entrepreneurially minded learning activities in each of our disciplines and publish them as Keen cards, which we have, and now we are moving on to bigger and better things. We got a new Keen grant that started at the beginning of 2019, and the goal of it was to provide evidence for entrepreneurially minded learning integration into making. We needed to connect to the maker world, how we should incorporate EML into making, and we're contributing to the making world right now. In fact, we're organizing making activities for the network, and we're starting to disseminate to the making world our best practices. We're going to make connections, establish best and worst practices to create value for the entire Keen network. And our goal is to make it such that no one has to reinvent the wheel, and so that aspiring engineers can satisfy their curiosity through construction of prototypes. The 3 words or phrases shown in red are keywords and buzz phrases within the Keen EML framework. Those are what we want to emphasize, and they want to emphasize in what we teach you besides the traditional engineering skill set. We want to incorporate a mindset. And so what are the key questions that we needed to address in this grant? What do students gain through making experiences and accomplish in making spaces? Are there some specific themes or use cases? What types of learning occurs in making spaces? Some of it's direct, some of it's not, and most of what's not is community centered, and that's a big part of the latent value gained from using Makerspaces. Are there opportunities to enhance the 3 C's that I mentioned on the previous slide with regard to making, and are those opportunities realized? I'm going to say yes. Can we improve those experiences? Yes, and we're figuring out right now how to best formalize and package that so that not just a few students gain from that, but so that every student has an opportunity to gain from that. And more so now, to do so in a COVID-19 world where some of what we've learned has to be translated such that it can be taught in a remote environment. In year 1 of our 3-year Keen grant, we put together a survey to identify who the key players in making are at each Keen school, and then followed that up with a more in-depth survey that was built into the end of year 1 report and presented at the January 2020 Keen National Conference about passable pathways to coming up with successful making environments, and we're continuing to come up with such pathways now that we're later in 2020, and will continue to do so throughout part of the rest of the grant. And what our goal in this is to create value for the entire Keen network by reducing the learning curve with regard to making. And some of that's changed in 2020 due to the COVID situation. We're trying to make it even more transferable into remote situations. That second summer survey that we put together helped us to determine who the partners were for year two tool development. Those partners are George Fox University, Lawrence Tech, and University of Denver. When we speak of making environment, we're looking at a much broader view than most people do. Uh, in our way of looking at things, it's everything from ideation through design all the way to reality as you go on the bottom from left to right. So you've got to be able to visualize it, put it into CAD drawing, and maybe enable that a little bit more with some virtual or augmented reality, uh, as we have in our university library. Makerspaces, we've got a couple of those. One of those is shown on the left. Uh, and we have community outreach and training. Near the middle of this, you see a student with the 3D printer that she built at one of our initial camps. Then ultimately moving toward our student design center, where students are able to build mostly senior design projects, but certainly not exclusively, as well as at the machine shop, where they get more traditional making tools. So the idea for how we were going to develop tools that could be distributed to the Keen network is laid out as follows. Florida Tech is School A, and we would partner with 3 other schools, creating 2 different tools with those schools, and then exchanging amongst the 4 so that there's a proper beta testing of them prior to them being distributed to the entire Keen network. Part of my responsibility as part of this project was to do a literature review on making education and where it's been and where it is going. There are a few review articles that I compiled all of this into a written document that is under review right now for publication, and the next 30 or so slides basically outline what is in that paper. And don't hesitate to email me at jbrenner@fit.edu to request a copy of that. There are a few review articles on this subject already, but none that really directly assess what I wanted to look at. What I wanted to look at fell into the following categories. The benefits, implications, and challenges associated with additive manufacturing, 3D printers in particular, its effect on creative thinking. If you can translate your ideas into a product, that opens up some innovation and invention possibilities that otherwise would not be possible and that you probably wouldn't consider. Makerspace startup requirements and options. One of the problems that we encountered as part of this was that there is a tendency for universities in particular, but makerspaces in general, to spend too much money on one or two very new pieces of equipment rather than getting lots of relatively inexpensive pieces of equipment, because ultimately part of the challenge here is that you've got a big campus that you've got to meet the needs of. Where it says open source versus exclusivity and sharing economies, this is a big challenge in the maker community. If you are going to sell your ideas and make money off of them, you've got to have some sort of added value that's going to bring people in. But most of what's out there is in the open source community, and it's difficult to make money off of, and many of your potential customers prioritize the low cost over an enhanced capability. With regard to community and psychological benefits, frequently a makerspace is a great gathering place for many students, and in particular students who wouldn't necessarily be extroverted, but like building things and are less likely to talk about them outside of a maker environment. We wanted to spend a fair amount of time figuring out how makers think. They think differently than the rest of us. I talked a little bit about the importance of community and psychological benefits and the open source versus exclusivity. You're going to see that some of the subcategories overlap between the larger categories. But in this section, I wanted to focus on the unique aspects of a maker's mindset. They are definitely different than many of the rest of us. I wanted to cover the best practices with regard to STEM literacy of experienced makers and how that's different from inexperienced makers, and also focus on the effect of on creative thinking, since that's one of Keen's major focus areas. We wanted to figure out how to convert thought into design, and so that that makes us look at some areas within making that are not as looked at as they probably should be with regard to augmented and virtual reality, and often these are in libraries, and so they have to serve a larger community. I wanted students to, as well as educators and staff, to think about design for additive manufacturing and how that's going to not only change how you design, but it's also going to change how you're going to prototype. We wanted to have some time spent on what should be in each making environment. Most of the work that's been done in this area in prior years is focused on maker spaces at the pre-college level, although there certainly are some at the college level. And we wanted to get some input with regard to what small business thinks about maker spaces. They tend to recruit heavily from maker spaces because the students who participate in making tend to be much more independent when they graduate. One major challenge that I haven't talked about yet is the business model for making environments, and in particular Fab Labs were invented with a specific set of requirements and charters that evolved out of MIT. But putting together a good business model for making is a major challenge that has not been solved yet, and I want to talk some about that in this talk. There have been several ways to teach the making content, and I think that after having done the literature review, the touring of several universities throughout the Keen network, and then developing a 3-credit making class myself, we figured out some things that work better than others. Should you have a 1-week summer camp, as we've done in the past? Should you have 2 to 3 hour workshops, either a la carte or as part of a series? That one we've tried, and we found that because you didn't have the same people every week, there was a lot of variability in the incoming prerequisite knowledge, and it made it very difficult to teach these sorts of workshops. Machine shop certification courses. How do you get qualified, and how do you teach that sort of thing? And then with regard to courses that have a heavy making content, where you actually not only learn all of the making skills, but encapsulate that into a design and prototyping experience. Frequently those are in 3-credit semester-long courses, and we've developed such a course. There are pluses and minuses to all of these, and now one of the concerns is how you teach this in a COVID world, and so transitioning all of this to a remote learning environment has presented some new challenges. One of the big differences between big universities and small universities is whether they've got 1 or 2 makerspace environments, or several that are discipline specific. And the size of the university dramatically affects what sorts of tools you want to focus on. Should you have a bunch of distributed places that are going to be discipline specific, or one major consolidated space so that you make it much easier to get lots of different tasks done in one space. Several of you are familiar with Ohio Northern's expanded 3 C's, in addition to the traditional Keen 3 C's of curiosity, connections, and creating value. In this article by Burrs et al., there are 6 C's, some of which overlap and some of which don't, where you translate caring, connection, contribution, competence, confidence, and character into behaviors such as collaboration, i.e. Making the people connections. Communication does involve some of the intellectual connections as well. Community building, content creation, creativity, and choices of conduct. This slide summarizes the administration of university makerspaces, and it's a collaborative work between James Madison University and Georgia Tech, including several faculty who are part of the Keen network, like Robert Noggle, and includes a Venn diagram showing the administrative responsibilities for makerspaces. Some are faculty run, some are staff run, and some are student run, and then some are combinations thereof. And while this isn't a complete list, uh, it does summarize uh, many of the uh, maker spaces at top 100 research universities. From that same article, you can see which universities have which maker spaces, what their names are, and how to get access to each of those maker spaces websites. Uh, we are going to do some of that as part of our final report for this particular grant. But at least this is a start. Some of these are uh, universities within the Keen network. On the previous page there was Drexel. On this one there's Duke, Georgia Tech, Lehigh. Let's see. I think that's it on this page, but several of the other schools that are listed here do send individual faculty to the Keen National Conference as well. And this is the last of the list that I have pulled from the James Madison Georgia Tech collaboration on university makerspaces. Other universities within the Keen network that are on this list include University of North Carolina at Chapel Hill and Vanderbilt. In that same article, you also can find whether the spaces are on or off campus, whether they're run by departments, entire colleges of engineering, and whether there's some sort of fee associated with them or not, whether they're open to the community or not. This is more of the same, but for more universities. That same article, which is clearly the most comprehensive of its type with regard to the university makerspaces up until now, you also see what the various tools that were available in 2014 at each of those universities are. Apparently I forgot to mention Arizona State as one of the universities that right at the top of this list. But you can see that what is expected at each of these universities is a 3D printer, laser cutting, wood shop, metal shop, electronics, perhaps a textile capability, and for those of you who think that sewing is not important, it is far more important than you might think, especially to our female population. Whether you've got a separate computer room for CAD drawing is important, along with some whiteboards. One of the reasons why you don't see whiteboards checked very often is because that's almost become an expectation now. Now I'm going to transition to how familiar are you with 3D printing? What do you use 3D printing for? And do you make your files yourself? There is quite a big difference between whether or not somebody makes their files themselves versus just use 3D printing. A surprisingly large percentage of people who claim to be capable of doing 3D printing fall into the good enough category, even though they don't make their files themselves. They just find something on the internet and print it. There is some work on the benefits of makerspaces for workforce development as well. Uh, some of the things that you see as benefits from it are confidence, creativity, engagement, particularly of people who might not otherwise be quite as talkative. They will talk about how to make something with somebody who is either more or less or the same level of competence as they are. The hands-on participation. Uh, Whether or not uh, you have a presentation method that's going to be effective for people. A fair number of these people just go on to a website, download it, and try to do it themselves, and many of them develop independent skills as a result of that. But often you wind up seeing that they develop collaborations with the people with whom they are downloading things off of the internet. You're probably thinking, well, how do they do that if the people are on the internet? You'd be surprised at the number of emails and eventually phone calls that developed from that sort of website search. Specific to the educational setting, you can see some benefits as well. One of the better articles on uh, the relationship between how people think and the formation of a maker is summarized in this slide that was developed in part by Landa and Jordan, then of Arizona State. I think Jordan's still there, but Micah Landa is now at South Dakota School of Mines, and I talk with him once in a while. Uh, this this article here shows the relationships between how people think and how they relate. Much of what they do in terms of material and social discoursing uh, comes out of what they want to do in terms of making. So this is a primary socialization method for many of your makers.